This lesson is on solving systems of linear equations by addition. It's an alternate method for solving systems of linear equations by substitution. Sometimes it's more useful to use this method, especially when you have your two variables lining up very nicely and they can be easily added together, as you will see in some of the examples. For example, say you had 2x plus y equals 3 and x minus y equals 3. We can use substitution if we like. We could use graphing if we like. However, in this case, our x terms and our y terms are nicely lined up. Notice that if you line up the equation, line up your variables and your numbers so that they all correspond, you can add the two equations together and see what happens. So let's see what would happen if we put all of the left side together and all of the right side together. If you're not sure why this is happening and why this works, think of a balance scale, which can often be used to represent an equation. If you took two items that were equal to begin with and two other items that were also equal and put them on another scale in succession like so, they would still balance out. So let's add these up. 2x plus x gives us 3x. 1y minus 1y gives us 0 y's. So our y's cancel out, leaving us with, and we have to add these as well, 3 plus 3 is 6. This leaves us with a nice equation where one of our variables were eliminated. So the addition method is sometimes also called the method of elimination, because our whole goal with the method is to eliminate one of the variables to have an equation with the other variable, which we now can solve, and we're left with x equals 2. So you can see that this can sometimes, often, form a shortcut for you when solving systems of equations. If we know that one variable is 2, we can choose either one of the equations from above and make sure that we know what the y is. So let's take the easier one, which is x minus y equals 3. There's less stuff on it. Plug in the 2. 2 minus y is 3. So 2 minus what is 3? Well, 2 minus negative 1 would give you 3, because 2 plus 1 is 3. You could just solve it the other way as well. Either way, you get y equals negative 1. So 2 comma negative 1 is a solution, and you can check that in both of those original equations. The first example lined up very nicely. How does this one line up? Well, our x's, y's, and numbers are lined up. That's great. However, if we added, none of these would disappear. But remember that you can take any equation and you can always multiply an entire equation by any number that you like. So that is something we can do. Notice that we have 1x and 1x. What if we had negative x's here? Well, that would mean we would have to multiply every single item in the second equation by a negative 1, which would cause this to be negative x minus 2y plus 3. So that gives us, when we add it up together, x minus x is 0. That's just gone. Negative 3y minus 2y is negative 5y. And 2 plus 3 is 5. This leaves us with a new equation that is simple to solve. One variable only. Divide by negative 5 on both sides, and you get y equals negative 1. Pick an equation that you want to choose to replace your y with a negative 1 and solve for the other variable. So x plus 3 is 2, minus the 3 from both sides, you get 2 minus 3 is negative 1 as well. So -1, -1 should be a solution to this system of equations, and you can check it out yourself. Let's move on to an example where our coefficients are different as well. So remember, the goal is to eliminate one variable when adding the equations. Let's take a look at this example. You have a few options here. You could try to eliminate the x, or you could try to eliminate the y. It really is your choice. If you try to eliminate the x, you'd have to either multiply the top by -3, because that would make that a -9, or you'd have to divide the entire bottom by a -3, which won't work. So we could multiply the top by -3. That's one option. You can try that and see how it works. Also, you could try to eliminate the y. It really doesn't matter. What would we do if we wanted to get rid of the y? Well, in that case, we'd want both of these to be 4, so we'd want to multiply the bottom by 2. And it's already negative, so it will cancel. Let's do that. Let's multiply the bottom by 2. So we have 3x plus 4y equals -5, and the bottom equation is 18x minus 4y equals 26. When we add those together, what we want happens because 4y minus 4y is 0. 18 plus 3 is 21x, and 26 plus -5 is 21, giving us x equal 1. Now we can plug it back into either of the equations, so you have a lot of choice here. Play around with these, try and solve this same equation in a different way and see if you get it. So we got 3 plus 4y equals -5. Subtract 3 from both sides, you get 4y equals -8, and y equals -2. So your 1, -2 should be your answer. Let's continue. Recall, you first always need to have things lined up. Line up like terms. Then you want to eliminate one variable, and then you want to solve for both variables, etc. So let's get these lined up. The top equation has its x and y in the same positions, but the bottom one is a little spread out. So let's clean the bottom one up. We'll have 3x, we'll subtract the 2y, so it's on this side. We'll minus the 1, so it's on this side. So that gives us 3x minus 2y is equal to 12 minus 1, which is 11, and that's a bit more cleaned up now. So we've got 2x plus 5y equals 1, and 3x minus 2y is 11. We need to multiply one of these equations so that one of our variables disappears. Now, you really could choose either one. Let's choose the y because we already have a negative. So let's multiply. We actually need to multiply both here because the 5 and the 2 can't be made into each other directly. So then the top equation would have to be multiplied by a 2, and the bottom equation would have to be multiplied by a 5. That way, we end up with 4x plus 10y equals 2, and 15x minus 10y equals 55. Note that if you wanted your x's to disappear, you'd want to multiply your top by 3 and your bottom by -2 so that you'd have 6 minus 6. Let's continue with this option here. 15 plus 4 is 19x, 10 minus 10 is 0, and 55 plus 2 is 57. Let's see, does 19 go into 57? Yes, it does. It goes in 3 times. So x is 3. Now you can take any one of your equations and plug in to solve for y. So 2 times x plus 5y equals 1. X is 3, so 6 plus 5y is 1. 5y is equal to 1 minus 6, which is negative 5. Y equals negative 1. You can check that in both your equations and see if it works. So 3 comma negative 1 should be the solution. Let's continue. In this equation, we could either eliminate our x or our y. Let's try eliminating our x, because that's the first thing that I noticed, but you could have noticed the y's. So I'm going to choose to multiply the top equation by negative 3. That way I'll have negative 3x and plus 3x giving us 0x. So that gives me negative 3x minus 9y equals negative 9. Put the bottom equation down, and that gives us, hey, wait a second, we were only trying to eliminate the x, but in the process, we're actually eliminating our y as well. So, what to do now? This is very normal. If this happens, think clearly, what is it giving you? What happens when these subtract? You're not left with an x, you're not left with a y, you're left with 0 x's and 0 y's, which is 0. So put a 0. Negative 9 plus 9 also gives us 0. So put a 0. It's fine. Now we see that 0 equals 0, and we know that that's true. That makes us happy. So essentially, that means that anything could work. Any x-y pair could work in these equations. Anything that works for the first equation or the second equation will work for both. Meaning, this is one of those examples where the line is actually the same. So since it's the same, our answer is going to tell us that the solutions to this problem are ones that satisfy the line equation x plus 3y equals 3. Let's take a look at this example. This one looks lined up, but it's not because the equal sign is not lined up. So let's take the first equation and fix it up here. So minus 3y, we got 3x minus 3y equals 4. And the bottom equation gives us 6x minus 6y equals 5. Let's try to eliminate one of the variables. So let's try and eliminate the x. In doing so, we want to multiply the top by a negative 2. That results in negative 6x plus 6y equals negative 8. And the bottom equation stays the same, 6x minus 6y equals 5. Let's add those up. Whoa, we get 0 again on the left, and on the right we get negative 3. In this case, these are not equal, and so this is an example of having no solution.